Hello, hello. Am I audible? Hello, everyone. Am I audible? Hi, Dipesh. Are you there?
Yeah, hi Rohini. Yes, you are audible. I think we still have 10 minutes left. Let's wait for 10 minutes, then we'll start at 8 o'clock. Okay.
Okay. Hi, everyone. Whoever joined, do share the webinar live link to your friends. Let them learn something new.
Okay, so it's 8 o'clock. Let's start. So, first of all, hi everyone. Welcome to one more exciting event of Mumbai Techie Group. So, first, who don't know about the Mumbai Techie Group, let me give a small introduction about it. So, we are basically a technical group. Okay, we organize the webinars, seminars with the industry experts with free of cost. Mumbai Tech Group not only help people in improving their technical skill, but also help with their networking. My name is Deepesh Shinde, and I am currently with Preeti Redgure, leading the Mumbai Techie Group. You might see me sometimes doing some sessions as well. We have already planned, some new sessions in upcoming dates to keep to get the updates. You can go to our Mumbai Techie Group Facebook page, or you can join our Telegram group. In that sorry, in case you want to, you are interested in sharing your knowledge with other people, let us know. You can drop an email to admin at the Mumbai Techie Group com, or can ping us in any social media. Remember, sharing is caring. By sharing our knowledge, we somehow saying thanks to our social everyone. With that, let's jump to our today's topic. So today's topic is going to be conducted by Rohini Sharda Parade, who is part of the software industry from last 6 years. We are fortunate that we are going to learn something new from her today. So, without further ado, I'm passing the mic to Rohini.
Yeah, Dipesh, thanks for the introduction. And yeah, hi everyone. Let's start today's deep dive and understanding the SQL Server world. So, without wasting the time, let's start with the query tuning. So, being a SQL developer, everyone have the common problem, which is query taking a time. Initially, when we write a query, it runs really quick, like it runs within a 1 second. But as our application grows, data increases, and with the data increase, our query start taking time. That is because while developing a query, we need to take care some points. So today we are going to see what those points are, and even your query is taking time, what changes you can make so it can get little bit faster. So let's start with the first point. Okay, whenever we are writing a query, okay, whenever we are writing a query, we sometimes we write a sub queries. Okay, so here I have written a two version. My requirement is I want I want a number of order placed by any customer. So here I have written a two queries. Okay, both query returns a same output. Okay, so in first query, what I have done is I have written a sub query for sales order header table and grouped it by customer ID. And I have done a inner join with the customer table so that we can get to know how many order placed by that customer. So let's see how uh, how it's how query runs. Okay, query have run within 1 seconds and it have retrieved 19,119 row. Okay, and let's see what is. I have a second version which does not contain a subquery. This is a simple query which with a inner join. Okay, so i will run I will run this query and let's see the output of the query. Okay, so similarly, this query also executed in 0 second and return 19,119 row. So we have seen both the query have written a same number of rows. So what is difference between in those queries? Let's see. let's see the execution plan of these queries. Okay, I will execute the queries. Okay, so let's analyze its execution plan. So, so first execution plan, the we are looking after is the plan of subquery section, and the second plan is the normal query which we have written. So both the queries, we are looking at both the plans. Both the plans looking similar. Can you see any difference in that both the plans? Both the plan contains index scan for both the table, for customer as well as sales order header. But is there any difference? Yes, there is a small difference, which is compute scalar. Okay, here you can see a compute scalar while it is doing customer table join. Okay, but here there is no compute scalar. So what is compute scalar? Okay, so in SQL Server, compute scalar operator is used to calculate a new value from the existing row value by performing a scalar computing operation that results a computed value. That means whenever we look at this first query, first operation takes place is in with the subquery. That means uh, at first place our subquery gets executed, our SQL server gets that result, and then afterward it joins with the customer table. Okay, that means there is little bit time increase when SQL server executes the subquery and gets that result. There little bit time is increased. So it is always considered as a best that writing a simple and plain query. If you want to write a subquery, then we can store that subquery result in any temp table and directly join that temporary table with our main query. So let's move out to our next topic. Okay, what the next topic is difference between union and union all. Okay, so there is major, like there is difference between what is difference between union and union all. So union returns a distinct record written by both the queries, whereas union all returns all the records written by both the queries. Okay, so let's see what is the output of a first query. Let's check it out. I will execute the first query. So see, query executed in 1 second and return 31,406 row, which is with union. Okay, and let's execute this union all query and let's check what is the output. So again, the union all query executed in 0 second and return 62,930 records. So let's check both the queries execution plan. So first execution plan is of union query and second execution plan is of union all query. So can you see the difference in both the queries? Yes, it is distinct sort operation performed in a union query. Okay, so what happens in a union query? So in a union query, the our SQL server performs distinct operation before returning the result. That means something happens when our main query executed and the result is returned. Whereas in union all, our query is executed directly and SQL server don't have to perform any operation to return a distinct result. That's why union query is slower than union all. So whenever it is possible, always use union all. And as you can see, related to query cost, here we have used 84% of our CPU, whereas here we have used 16% of a CPU. So union all is always cost efficient um, when we consider union and union all. So let's move to our next topic, which is over. So over window functions. So till now we have learned about what is difference between union and union all, and what is why we should not write subqueries. So let's see what is window functions. Okay, in that window function we are looking specifically for the over function. So SQL server provides various types of window functions like sum, average. So and over is one of them. So these windows functions makes our life easy. Okay, so let's see why where we can use over function. Okay, so let's see. Suppose we have a scenario where we want to find, let's say, number number of transactions, let's say cost of a cost of a sale of a product for each date. Okay, so for that, what we can see, what we can do. So here what I have done is I have taken a transaction history table. In that transaction history table I am checking for particular date, for each date, how many sale is happened for that particular product. So for that output, what I did is I have done I have written group by statement, and in that group by statement I have used product ID and a transaction date, and I have added all the cost of that product. So let's see what is the output of this query. So total 332 records of rows affected, and here we have we have got each product and at what day how many sale is happened. So let's see what we can achieve this by over function as well, but there is major difference. Group by function returns you a distinct data, whereas over functions does not impacts your data. It just simply sums the all costs. So let's see, if suppose I remove this, and let's check what is the output of this. So here we can see total 2278 rows affected, and here we can see for each date there is redundant data. Okay, but it all contains same cost. That means it have it have added calculated cost for each row, each date, and for each product, but at the same time it have not returned a distinct data. Okay, so this is the alternative method where we can use other than group by. Okay, let's see, we have a scenario, okay, where we have to sum total the say amount or anything, any integer value to that row level. For example, let's see, let's check the output of above query. Okay, let's check the output of both. We will execute both the queries and let's check the output. So here, see, here for product uh, product 707 and transaction date 2013 731, we have so many records. Okay, and what I want is, for each row I just want to accumulate the previous cost as well. For example, this is the normal details, simple details, but what I want is, for each row I want to add previous row's cost. So here is the output. See, here first row is showing cost 2.994 and second row is also having 2.994 cost, but at, at a below output, our first row is containing cost of 2.994, but our second row's cost is 41.988. That means we have added the amount of previous cost of previous row in the current row. Similarly, we can see as we go down, the our cost is getting increased. That means the row number 13 contains a sum total of previous row's cost. Okay, and it goes on increasing till for that particular date. Okay, we can see, and even here we can see previous date is 2013 731, below date is 2013 81. Okay, and even in this transaction also we can see the row number. See, row number 52 in above section and row number 52 of below section. Okay, so both are starting. Okay, so row number 47 of above section and row number 52 of below section, so both are starting with a different thing. Okay, though both are starting with 34.99, but it goes on increasing. So this is how, this is powerful over function, window function provided by SQL server. So whenever we require such type of calculation where we have to sum total um, any integer value in our current row, so we can use this over query, over function query. So if anyone have any doubt, you can comment in a chat section and I will try to answer it. So so let's move to the next part of our SQL query optimization session, which is common table expression. So what is common table expression? So, SQL Server provides one of the most powerful technique to create a virtual table while performing certain transactions. So, we did not need to declare the temp table or table variable. We can just use city and we are ready to go for the calculation. So let's see what is city and how can we use it. Okay, so I have over here, I have used a transaction history table again. So let's see how many amount of data it contains. So our transaction history table contains 1,13,443 rows. Okay, then let's execute our next query. Okay, which is our next query. What we are doing in our next query? In our next query, we are calculating total. Again, we are calculating number of cells, number of cells by each product. So what we have done, we have sum all the standard cost, okay, for particular that start day, okay, and inserted it into a one temp table which is transaction history copy. Okay, so let's execute this. Sorry, this table is already exist in our database, so let's quickly drop this table. Okay, and let's execute this query again. Okay, and let's see what our transaction history copy table contains. Okay, it contains 395 rows. Okay, and if we look at here, see, for product 707, okay, it contains a duplicate entry. That means over here, if we look here, somewhere we can see a duplicate entry. For example, 2011 531, we see a double entries. So if we want to eliminate a duplicate record, what we can do over here? Let's see. I just want to eliminate the duplicate entries from our table. Okay, okay, so let's see. So I have created city. Okay, so city, this is the city. Okay, so this is the city syntax where we first write semicolon, then write a with keyword, and then write our city name. Mostly every developer, there is some standard defined by a developer, so we write city initially so that we can recognize it as a city while doing operation on that city. So, and we are using as keyword, okay, to just start the city. Okay, and within these round braces we can write a query, whatever query we want to write. Okay, let's execute this, and let's execute this and see what is the output. Sorry, let me explain what I have written in this query. Okay, so in this query, what I did is I have given a row number, okay, to each row by partitioning it with the product ID and start date. Okay, if we execute this query, we can see the output. See, this is 1 2 3, means for this product ID I am having these duplicates record. Okay, this, because we have partitioned it by product ID and order by it as a start date, means the higher higher is the start date, uh, lesser is the start date, it will get a first number, and then so on it will get increased for that particular row, particular product ID. So let's check what happens if I execute this. If we see the output, it contains 293 for product 707, there is only single entry is present. That means whenever we are using any table in a city and perform delete operation on that city, explicitly records are getting removed in your from your main table. Okay, so city is this much powerful. What city does it creates a virtual table which can be used in your transactions. So you need not to worry about the declaring a table and after deleting it. So let's drop our copy transaction table which we have created. So this is one use of city for deleting a duplicate record. There is another use of the city which is recursion. Okay, might be you all knows who are in a from coding background, you all that all them are know what is recursion. What is recursion? That is certain code we are executing it repeatedly, it is called a recursion. Okay, we in a object oriented programming we can achieve it through a functions. Okay, even in a SQL server as well we can achieve it through the functions. But does there any other option rather than function or rather than using while loop? Yes, there is a option which is also CT. Okay, let's see how CT works for a recursion. Okay, if we see here, I have here declared a city. Okay, let me explain what this piece of code means for. So initially I have written one select statement which starts with the one number assigned to a n field. Okay, this is the initial part or say anchor member of our city. This initializes our recursion. Okay, you can execute this part, you can see the output of your initial part. But when when we go further, like when we go main part, that is recursion part, which will gonna execute it repeatedly. Okay, this you cannot execute because your city is not initialized yet. Okay, so let's see what this city will return. Let me execute this. So see the output. So we have got a column whose headline is n and who is returning us a number from 1 to 101. So what does it means? Okay, what does it means? That so here we have initialized a number n and this we have assigned n a value of 1, and in recursion part with every iteration we are increasing that n by 1. Okay, and this recursion will go till 101 till n's value did not reach to the 101. Okay, what happens if I remove this and execute this again? Let's see. So here is an error. The statement terminated the maximum recursion 100 has been executed before the statement completion. That means we don't have a termination point to this city. Okay, that means our loop will go on and on because we don't have any breakpoint. So by using where clause we apply it as a breakpoint. Okay, even applying a where clause if you don't know like if you think that your city even will not stop even after using a where clause, so max re- there comes a there comes a SQL hints, okay, that is max recursion or something, but there is one hint. So you can limit the maximum number of iteration can be possible. If your city goes beyond that iteration declared by you, your SQL server automatically stops your city and returns the result. So that is the power of city. So let's see the real world example. Here I have created a table I have created a table people, okay. In that people, I have maintained a hierarchy. That means person A, ABC is higher of A1 and ABC1 and ABC2, okay. PQR and PQR2 is lower of number ID 3, okay. And XYZ is lower of fifth number PQR2, okay. So what I want is, this is some kind of tree, means 6 belongs to ID 5, 4 5 and 4 belongs to ID 1, 4 and 5 belongs to ID 3, and ID 2 and 3 belongs to ID 1. This forms some sort of tree. And what I want is this hierarchy. I just want a name of that name of that belongings, okay. So let's check how can we achieve it. So so this scenario can be encountered where we have a employee table where each employee is reporting to some other employee, okay, means one is senior and one is junior. So here we will just what I let me explain what this piece of code means for. First is our start point, where we are taking the initialization of our recursion, okay, where we are giving a initial input. So we are taking the highest person who is not reporting to anyone, okay, and afterward we are iterating through the each and every person, okay. So let's check the output of our first query, which is AB, which does not have anyone reporting. So let's check, and here what I did is, with a people's table I have joined the city, means we are storing our output in the city, and again we are joining recursively with the main table. So let's see what output this query returns. So I'm executing this query. So so what is the output? So output this query is giving is, see, ABC does not reporting anyone. So that's why we have replicated its name to itself. So, but ABC1 and ABC2 is reporting to ABC. We have a reporting name and plus the level. So, here is ABC is highest person who is not reporting to anyone, but 2 and 3, that is ABC1 and ABC2 is reporting ABC, and who is having rank of 2, okay, and 4 and 5, that is PQR and PQR2 is reporting to ABC2, and they are having rank of 3. Similarly, XYZ reporting to XYZ is reporting to PQR2 and having the lowest level, that is 4. So this is how our city recursion works. So till now, anyone have any doubt? You can ask in our chat section. So I think no one have any doubts. So let's start with the major part, major role played by indexes. So the, whenever we are dealing large number of data, okay, let's say we are having crores of records in a particular table, then it gets difficult to perform some operation on that table. So to overcome with this for this problem, SQL server have a indexes. So what is indexes? So what is indexes? Indexes means we are providing a references, okay. So there are two types of indexes, clustered index and non-clustered indexes. So clustered index, a clustered index determines the physical order of a data in the table. There can be only one clustered index per table. That means students standing in a roll number wise. So whenever whenever we refer to a clustered index, clustered index, what clustered index does is, whenever we are inserting data in a table, let's say let's say we have a student table and we have given a roll number as a we have set a clustered index to a roll number. So what happens, every time new new roll number comes, our whole table is getting sorted with that roll number, okay. And whenever we declared a clustered index to a table, it is stored in a sorted format. What is not clustered index? A non-clustered index does not dictate the physical order of the data. That means it does not store a data in a sorted form. Actually, data remains as it is whenever we are inserting data. But multiple non-clustered index can be created on a single table. Okay, so so for the example of clustered index, non-clustered index is book index. So what is difference between this clustered and non-clustered index? So we know the book index. What book index actually indicate? It just showing that this chapter is starting from line number 23. That means you can find this chapter to line number 23 so that we can directly jump to line number 23, okay. But whenever we are making students stand roll wise, so we know that roll number 5 will be located after 5 steps. So this is the major difference between cluster index and non-clustered index. Cluster index stores the data in a sorted format and non-clustered data does not affect insertion of data. It just simply creates a reference and stored it in a memory, okay. Let's skip this part, we will discuss this further, okay. So now we have seen what is clustered index and what is non-clustered index, okay. Let's see the demo of the non-clustered index. So here what I have done is, I have just written a query which is returning me product IDs who have a order quantity greater than 4. Okay, and product ID is 77. So how many let's check how many number of rows affected. So total 49 rows affected by this query. Then we have converted this query to a input parameter. Like instead of providing directly hard coded number, we have stored it in a local variable and retrieve the data. Let's check what is the difference. Let's check the query execution plan of both of them. Check what is the difference between them. See, there is a difference. Okay, in above query it is looking after index seek, and in the below query it is looking after the index scan. Okay, let me tell you what is the index seek and what is the index scan. Okay, when its name suggests, what is seek and what is scan. Scanning means scanning the entire thing. When we are scanning document, that means we are looking after each and every word, each and every row. And what is meant by seeking? Seeking means we are getting that thing directly, means we know this thing is, I will get this thing, this particular thing after 4 steps, after 3 steps. This means seeking, and scanning means scanning entire things. So as we understood what is index seek and index scan, one of the most cost efficient thing is index seek, because it does not take whole round trip of your table. It just recognize the place and it just pick it up. But when it's come to index scan, it visit your each and every row. So this is costly operation. So, and while creating index, okay, when we are dealing with the index, SQL server is smart enough to provide you the information where which index is lacking. So what you can do here, we can see our SQL server is suggesting us to create a non-cluster index on product ID and order quantity. So what we can do, let's see, let's, so it, our SQL server is giving us a suggestion, but does you have to write a separate query after looking this? No. There comes a option. Okay, so here missing, whenever you click missing index detail, what SQL server does, just gives you a complete syntax on the new query window. So let's copy this. Actually I have already copied this, so I will just close this, and what I will do is I will just create an index suggested by our SQL server. So I will just run this and we are good to go. So what we can do now, we have created index. Let's comment this portion and let's let's execute this. So so let's execute this. So first let's see with this only. Okay, let's execute this now and let's check with the query plan. So what our query plan literally looks like. Okay, Here we can see indexing. First, we have seen a index scan, which is more costly operation. Now it is converted to index seek, means it is costing less. So let's see. Now we have seen how we can create an index and how to analyze, how to identify where we have to create an index. Okay. Now let's move further. Let's say I have written a query where I have just used a product ID and product unit price is greater than 50. Does in at this point our SQL server picks index created by us? Let's check it out. Let's execute this. Let's generate query plan. Oh, sorry, my bad. Let's generate the query plan. Here is cluster index scan. Means it is scanning whole index. Sorry, whole table, each and every row. Now we understood that it is not picking index created by us. So let's so there is other option. There comes a SQL query options. We can provide hint, so our SQL server while executing picks that hint up and creates query plan accordingly. That means here it this is the hint we are providing with index and the index name. Here we are telling SQL server while executing this query, please pick this index. Let's check it out what the output it gives. So let's execute. Here is a index seek. Okay, and here we have seen previously same query is giving index scan, but after using hint it is picking index created by us. Okay, so let's check it out further. What suppose I don't want to use hint. Using hint is okay temporarily. If it is emergency, you want to fix some production issue, you can use a SQL server hints, but this is not good. To avoid this, what we can do then? For avoiding these index kind of hint, we can do just a small trick. We can just play a small trick with the SQL server. As we know, order quantity cannot be negative. So what we can do, we simply add and with the order quantity. As we know, order quantity will always be greater than 0. So this order quantity will not affect our result, but it can affect our query plan. How? Let's see. Let's execute this, and here is the thing, clustered index scan. So it have reduced the let's see, is supposed to pick it up. My bad. Let's see. Let's check it out. It provides an index seek when using this, but when we execute this, it is using index scan. Why so? Let's see, because we have unit price used in the where clause. So let's see what happens if we use a variable instead of a number. See, here it have used a index seek. So we can play a little bit trick with the SQL server, and here it was not picking index for executing the query, but just we played a small trick and it start picking our non-clustered index. So let's drop our index which we have created. Okay, it's done. And let's see. Okay, as we have seen, indexes makes our life easy when we are dealing with the transactions and a large number of data. But what does it does it mean good? Even medicines are good for the body, but if we take it in excess amount, it is harmful. It is harmful for our health. Like that only, if we overburden our table with the indexes, it is harmful for the for that table, or say our database. So let's see how it is harmful for our database. For that, I am using this Adventure Works EXT 2016 EXT database. With that, I am using this table which is having 10,000 1 crores of records. Currently, it is having more than 1 crores of record, but I am just simply selecting for 1 crore so that we can see the demo how it is poisonous for our table. So let's see what I have done. So here I have created a 4 index, which is first index consists of currency key and career tracking number. Second consists of career key, career tracking number and order date. And third one is composed of revisions, career and sales territory key. And third one consists of revision number, career tracking number and customer PO number. Okay, so we have 4 indexes in on our table, which is fact, reseller, sales, Excel page compressed. Okay, so let's see, if I select this 1 crore of record, how much time does it takes? So it's still going on and on. So let's check. The query executed in a in a 14 second. Okay, okay, let's check the amount of memory our indexes use. We have created a 4 index. First index is taking 6,99,456 KB of memory. Okay, each index we are creating, it is consuming some part of our SQL server memory. So creating more indexes consumes more amount of memory from your table. So always try to always try to avoid creating unnecessary index, because it affects your performance as well as storage. So let's see if we drop this indexes dropped and select this same, it is taking 9 seconds. Okay, but what if we create a single index, let's say this one, what happens? It will take more time, so I'm not executing it. So index helps you to boost performance, but at the same time creating unnecessary indexes can reduce your performance as well. So let's check what precaution we can take while creating indexes. Okay, so first point is analyze and understand the typical query pattern executed on your database. That means which which type of data is retrieved from your database. That means while customer details from customer table, customer name is retrieved mostly by using customer id. So what we can do, we can place clustered index on customer id and customer name. Okay, so these are the few points, mostly used columns we can put into our index. So next, let's see the next point. Resist and resist the temptation to create indexes on every column. As we have discussed, medicines are good for our health, but it is harmful when they are taken excessive amount. So similarly, do not create indexes if it is not necessary. Even SQL Server is suggesting we have workaround, plus first search for it, and if you don't have any option, then only create a indexes. Next point is evaluate the cardinality, number of distinct value of the indexes column. Okay, means place a index on a column which is having distinct less distinct value. Okay, then let's see the second another precaution. Prioritize indexing on a column with high selectivity, a large number of distinct value. That means that means place a place a index which is having large number of distinct values. Avoid creating redundant indexes that cover the same set of data. That means do not create indexes on same column with different name. Try to avoid it. Always before creating index, just look after present index which you are having on your table. So how you can look if our table contains that index or not? Simply select the table, press Alt plus F1, and here you can see the data related to your table. Here we have, here is the index details, which index our table contains. Okay, and what keys it is including. Okay, here we have a clustered index on sales order number and order line sales order line number. Okay, and The last one, understand the difference between clustered and non-clustered index. As we have discussed a most important point, okay, which is cluster index stores a data in a sorted format, and non-clustered data stores a reference in a memory. So when we are creating a non-clustered index, means we are just storing a reference, okay. It does take some time, but not that much as clustered index takes, because clustered index inserts the data and then performs a sort operation on your entire table. When you are dealing with the table who is mostly used in a transaction, then using a clustered index on a data which is frequently get changed can cause major issue with your table, and even can help you to crash your database. So if you want to avoid it, so just take a precaution. Indexing is the important factor, but we have a workaround for it. So whenever, as per my experience, whenever we are dealing with the query optimization, it is more over logical thing that than an analysis thing. Yes, we need a analysis part, but moreover we can use a basic logic and optimize our query. It is the last ever part you can do is you can take a help of execution plan, so you can optimize the query. But first, try to optimize your query by using a basic logic. And one short tip I can give to you is, when you are writing a query, always use inner joins in a main query, and try to avoid maximum number of left join in your main query. Instead of that, execute your inner join in a one set and then perform left join in another set. So it reduces join data, and eventually it reduces the cost to get that data. So friends, thanks for attending the session, and thanks to Mumbai user group for providing me this opportunity to share my knowledge with all of you guys. And happy coding. Stay tuned for the next session.